Today we're going to talk about how to create an engineering design project. In physics, we don't just do projects, we do engineering design projects. So this video is going to step you through the requirements and what sets this apart from just a regular end of unit project. So generally, engineering design projects are open-ended tasks where you have to create a solution. And in this particular class, we're going to do physical solutions, like where you're actually model building. There are multiple correct answers. So there is not only just one right way to do this, there's many right ways to do it. It's all about communication because the end result has to be some sort of documentation and presentation and sharing out your solution with an audience. This is about creativity and risk-taking. Creativity and risk-taking are intertwined. And creativity is a learnable skill. A lot of us somehow get to high school and we think, oh, I am creative or I am not creative. And that only solidifies as you get older. Every single one of us is creative. How we express that creativity is different. And it's really all about the freedom to fail. Now that may sound really weird to you, but it is really important that you understand that failure is an inherent part of the scientific endeavor. When you have a hypothesis, you don't know if it'll work. And your job is to test it to see the effects of what you're doing. And if you only test safe things that you already know the answer to, then you are never going to make any impact in your field. So your job now as a student is to learn, like, how do I tap into that creativity? What are the strategies that I can use to push my envelope so that I don't only stay in the safe zone when I'm doing something? So let's talk a little bit about the engineering design process. The engineering design process, sometimes it has 7 steps, sometimes 3, sometimes 5. There's tons of diagrams. I'll show you a few different versions. Generally, it has 7 steps that spiral in a never-ending feedback loop. And you can see it in this diagram here, where we usually start at identifying the problem, right? Defining the problem. And then we do some research, you do brainstorming, you make a plan, you create and or build a model, then you test the model, then you evaluate the model, and then you go back to improving your solution and start the process over again. You'll notice that you can re-enter the process at any one of these areas, right? So once you've gone through the process, you can then go back to improving your solution and entering back into the loop at either of these 2 areas. So that is, regardless, whatever you're doing, you'll notice at the end is sharing your results out with an audience, whether it's your collaborators or it's, your teacher or your partner, whatever it is. Here's another version of the engineering design process. This has 5 steps, and you'll notice that there's, that you're always going to re-enter at either the ask or the imagine stage. And this is a great little tool as well that you might want to look. And this is for an engineering program at North Carolina State. So this is not anything that isn't useful, right? This is taught in lots of different fields. And if you don't want to be an engineer, don't be scared of the name engineering design process, because this process is used even if you want to do whatever. If you're an artist, if you're in finance, if you're in graphic design, if you are a lawyer, right? This process is still going to be part of the solution to any problem. Just the medium that you're going to use and the task that you're asked to solve is different. Okay, but the process is not any different, right? You don't just have one right answer to any professional solution. So there are many websites available to explain it. Here's another design process. Just if you Google engineering design process, you'll get a million different websites. I'll give you a few others to do some research on so that you can flesh this out a little bit more. What makes the engineering design project different from a normal end of unit project that you may do in other classes? So first of all, we already talked about failure is not at all a flaw. So if you test something and your project fails, that's actually an essential component of the process. If your ideas and experiments don't fail occasionally, then you really aren't challenging yourself. Now, that doesn't mean that it's okay to never come up with a solution. You still need to keep going, but it's what you do in the face of that failure that's going to make it a good project. In our class, you are competing against yourself. So I am not setting you against each other. So you want to see if you can make the best possible product within the time constraints, because our issue, just like with anyone else, is always time. So if you're going to have 5 days or 5 weeks or 5 months, whatever it is, you're going to test and retest and retest and rebuild, right, over and over again until you run out of time. And then you're going to present the solution that you came up with. One major aspect of all engineering is efficiency, right? It's about using resources wisely to make the least expensive product and get the most value out of the materials that you use. So that's something that you want to think about, and that is really where, going from advanced to expert is going to lie, but keep it in the back of your mind as you're working. Right? Try to make it the lightest, smallest, most whatever, right? Fastest, like what will help you like push the envelope of when you're testing your project. It is your job to provide evidence, right? The number one key to an engineering design project is communicating and sharing your results. So your communication has to be spot on. And what is that going to look like? Well, it's going to mean taking a lot of pictures, video, creating data table to share your data, showing your calculation, works cited, right? All that stuff is going to be part of your documentation. So what's the goal? Right, so we've got 2 standards you're going to be assessed on. One is the engaging with content standard in our class, and the other is the engineering design cycle. So here is the standard, and we'll go through all of it. You've seen it before. We've been working all year on just getting to developing using the content mastery checkpoints. So that's making sure that you understand the meaning of all the terminology and that you can you have some expertise with it. And then we're going to pick up and go through how do you get to proficient and advanced and expert in a minute. Here is the engineering design process, our cycle. And on this, we haven't worked on this at all. So I'm going to give you some information about how to do beginning, developing, proficient, etc. So with beginning, this is just with a checkpoint. You have to get between 80 and 100% on the content mastery. The engineering design process to get beginning. You don't meet all the minimum requirements, but you hand in something that's relevant that will get you to beginning. To get developing, you've earned 100 on the content mastery checkpoint, and you meet the basic criteria as outlined by the rules and requirements of the assignment. And for the engineering design process, you're going to build a product that breaks no rules and works, right? So you haven't cut any corners. It's the spirit of the project. Provides documentary evidence of a finished product and final tests, and you include documentation of your idea web, the problem-solving setup, and the brainstorming at a minimum. That's the minimum documentary evidence that you need. Proficient, not only do you do all that, but you also apply terminology and concepts in the documentation of the assignment. And also you're going to really flesh out your brainstorming, generating a wide variety of ideas, weighing pros and cons before choosing one. With the engineering design process, you're going to build a product that meets all listed requirements and minimum standards for function, and the documentary evidence is submitted, but you may be missing things here and there, quantity details or steps that are important, and you show evidence of multiple iterations of the cycle. So you can't just hand in one iteration, right? You show multiple. That's usually at least 3. Showing systematic work over the given time period. In other words, you didn't just do it all in one day right before it was due. To help you work through this, I also have some Word documents that I will provide for you. So this is a template for developing, and it kind of gives you the steps, right? Gives several steps for getting through the beginning of this process. So you can see there's 7 steps to do. So you want to kind of work through those steps. We can talk through some of this, but this should help you, make sure that you complete that part. And then whatever you do, you're going to screenshot and upload. Okay, so that's the first part of this. And then to get to proficient is going to be, yeah, this one. So proficient, so this is all up to developing, right? And then it goes through what to do to progress to proficiency. So just read through this information and add it to your project. Okay, so that's the next part. So for advanced, here's the requirements for the engaging with content. When making decisions and weighing my range of solutions, you apply physics concepts. So you're not just like, what the heck, let me just try this, but you're actually using physics to make your decisions. You significantly investigate some ideas that are more unusual, right? So that you are using your creativity. You want to try some ideas and take pieces of things to come up with a solution that's unique. You're going to cite your sources of inspiration, whether that's internet sources or things in real life or experiences you've had. You really talk about that and develop that. And there's clear evidence that you push past mere completion. So you're not just doing it to get it done. In the engineering design process, you have a final working product that works well, and your presentation synthesizes the results of all your testing. So you demonstrate, like, here's all the things I tested, now I put it all together, and here's what I got. Your documentation clearly shows that you've used the steps of the engineering design process to guide the development of your solution. The design and research demonstrate application and use of physics ideas and concepts. So that's overlaps with the engaging with content, right? And you've, and that your product meets the criteria, but I've maybe seen the solution before. It's not your problem, but that's means that it's not as creative because it's not totally unique. Or your solution is over-engineered or inefficient. So you want to take a look. I'll also provide you with a template for that level. No, not that one. This one. So there'll be more steps here for you to follow that will enable you to get to the advanced level. We did that one, sorry. And we did that one. Oh yeah, so that was the advanced level. And then to get to expert, which you don't have to do, of course, there's a whole bunch of other details in order to get to that level because, expert is expert. So one of the things that you're going to really do here is you have to make some decisions. How am I going to best use my time? How much time do I have to use? And how can I use it efficiently? And that will help design your scope. Like, don't make sure you make a plan. I'll help walk you through some of that, but the rest of it is up to you.